Dear viewers, welcome to this lesson on quadratics. By the end of this lesson, you should be able to identify and factorize a quadratic expression. First of all, where do we use quadratics in real life? Let us have a look at some pictures. Tap water coming out from taps, rainbow, bridge, radar, hanging bridge. Common features in these pictures are these shapes. They are known as parabola and they are quadratic curves. What is a quadratic expression? It is an expression of the form ax squared plus bx plus c, where a, b, and c are real numbers, and a cannot be zero. A is the coefficient of x squared, b is the coefficient of x, and c is the constant term. Note that the highest power of x is 2. Let us see whether the following are quadratic expression. First, x squared can be written as 1x squared plus 0x plus 0. So a is equal to 1. Therefore, x squared is a quadratic expression. Second, 3x plus 5 can be written as 0x squared plus 3x plus 5. Here, note that a is equal to 0. Therefore, 3x plus 5 is not a quadratic expression. Third, 2 minus 4x plus 3x squared can be rewritten as 3x squared minus 4x plus 2. Here, a is equal to 3. Therefore, 2 minus 4x plus 3x squared is a quadratic expression. Fourth, 5x squared plus 3x plus 4. So here, a is equal to 5. Therefore, 5x squared plus 3x plus 4 is a quadratic expression. Do you remember this term? Factorization contains the word factor. Consider 6. We know that 6 is equal to 2 times 3. Thus, 2 and 3 are factors of 6. The process of expressing 6 as products of its factors is known as factorization. To factorize algebraic expression, consider 2 into x plus 1. If we expand 2 into x plus 1, we obtain 2x plus 2. The reverse process is known as factorization. Now consider factorization of quadratic expression where c is equal to 0. That is, to factorize ax squared plus bx. We can write ax squared plus bx as a times x plus bx. Note here that x is common. Therefore, we can rewrite it as x into ax plus b. Thus, to factorize ax squared plus bx, we have x into ax plus b, where x and ax plus b are factors of ax squared plus bx. Consider some example. Example 1. Factorize 2x squared plus 3x. 2x squared plus 3x can be written as 2 times x plus 3 times x. Observe here that x is common, so we can write x into 2x plus 3. So to factorize 2x squared plus 3x, we have x into 2x plus 3. Example 2, factorize 14x minus 7x squared. 14x minus 7x squared can be written as 7 times 2 times x minus 7 times x. Note here that 7 and x are common. So we can write 7x into 2 minus x. So to factorize 14x minus 7x, we have 7x into 2 minus x. To factorize x squared minus k squared, recall that x plus y into x minus y can be expanded to obtain x squared minus y squared. The reverse is factorization. That is, to factorize x squared minus y squared, we obtain x plus y into x minus y. Example 1, factorize x squared minus 25. X squared minus 25 can be written as x squared minus 5 squared. And this can be written as x plus 5 into x minus 5. Therefore, to factorize x squared minus 25, we have x plus 5 into x minus 5. Example 2, factorize 49 minus x squared. 49 minus x squared can be written as 7 squared minus x squared. And we can write it as 7 plus x into 7 minus x. Therefore, to factorize 49 minus x squared, we have 7 plus x into 7 minus x. Example 3, factorize 2x squared minus 18. Note here that we have a common factor of 2 in both terms. So we can write 2 times x squared minus 2 times 9. So 2 being common, we can write 2 into x squared minus 9. And this can further be written as 2 into x squared minus 3 squared, which is 2 into x plus 3 into x minus 3. So to factorize 2x squared minus 18, we have 2 into x plus 3 into x minus 3. We note that we cannot factorize x squared plus k squared. That is, we cannot factorize x squared plus 5 squared or x squared plus 9. Now, to factorize quadratic expression x squared plus bx plus c, that is, a is equal to 1. Recall that x plus 2 into x plus 3 can be expanded to obtain x into x plus 3 plus 2 into x plus 3. This can be further expanded to obtain x squared plus 3x plus 2x plus 6, then simplified to obtain x squared plus 5x plus 6. So, when we expand x plus 2 into x plus 3, we obtain x squared plus 5x plus 6. The reverse process is factorization. So, when we factorize x squared plus 5x plus 6, we obtain x plus 2 into x plus 3, where x plus 2 and x plus 3 are factors of x squared plus 5x plus 6. Note here that 6 is the product of 2 and 3, whereas 5 is the sum of 2 and 3. In general, to factorize x squared plus bx plus c, we find two factors of C whose sum is B. For instance, if factors of C are P and Q, then x squared plus bx plus c equals to x plus p into x plus q, where c is the product of p and q, and b is the sum of p and q. Example 1. Factorize part A, x squared plus 5x minus 6, part B, x squared minus 5 minus 6. X squared plus 5x minus 6. Observe here that the product is minus 6 and the sum is 5. So to factorize x squared plus 5x minus 6, we need two factors of negative 6 whose sum is 5. So let us find the factors of negative 6. We know that negative 1 times 6 is equal to negative 6. 1 times negative 6 is equal to negative 6. Negative 2 times 3 equals to negative 6. And 2 times negative 3 is equal to negative 6. So the factors of 6 are negative 1, 6, 1, negative 6, negative 2, 3, 2, negative 3. So in the first case, negative 1 plus 6 is equal to 5. 1 plus negative 6 is equal to negative 5. Minus 2 plus 3 is equal to 1. And 2 plus negative 3 is equal to 1. So in this case, the sum is 5. So the factors we're looking for are negative 1 and 6. Therefore, to factorize x squared plus 5x minus 6, we have x minus 1 into x plus 6, where x minus 1 and x plus 6 are factors of x squared plus 5x minus 6. Part B, x squared minus 5x minus 6, product is equal to negative 6, sum equals to negative 5. So again, we need to look for factors of negative 6. So this has already been done in part A. So here we want sum to be negative 5. This corresponds to the factors 1, negative 6. So to factorize x squared minus 5x minus 6, we have x plus 1 into x minus 6. Example 2, factorize part A, x squared minus 7x plus 10, part B, x squared plus x minus 20. X squared minus 7x plus 10, product is 10, sum is negative 7. So we need two factors of 10 whose sum is negative 7. We know that 1 times 10 is 10. 1 plus 10 is 11. We know that 2 times 5 is 10, but 2 plus 5 is 7. We know that negative 1 times negative 10 is 10, but negative 1 plus negative 10 is negative 11. We also know that negative 2 times negative 5 is 10. Negative 2 plus negative 5 is 7. Therefore, the factors we're looking for are negative 2 and negative 5. So when we factorize x squared minus 7x plus 10, we have x minus 2 into x minus 5. Part B, x squared plus x minus 20 can be rewritten as x squared plus 1x minus 20. The product here is negative 20 and the sum is 1. So here we need two factors of negative 20 whose sum is 1. But we know that negative 4 times 5 gives negative 20 and negative 4 plus 5 is 1. Therefore, the factors are minus 4 and 5. So when we factorize x squared plus x minus 20, we obtain x minus 4 into x plus 5. Example 3, factorize 2x squared plus 6x plus 4. 2x squared plus 6x plus 4 can be rewritten as 2 into x squared plus 3x plus 2, as there is a common factor of 2 in each of the three terms. Here, we need to factorize this quadratic expression. Note here, the product is 2 and the sum is 3. That is, we need two factors of 2 whose sum is 3. We know that 1 times 2 is 2, but 1 plus 2 is 3. So the factors we're looking for are 1 and 2. So when we factorize x squared plus 3x plus 2, we obtain x plus 1 into x plus 2. Therefore, when we factorize 2x squared plus 6x plus 4, we obtain 2 into x plus 1 into x plus 2. To sum up what we have covered in this lesson, we identify a quadratic expression as ax squared plus bx plus c, where a is not equal to 0. For example, 3x squared plus 5x plus 2. We also factorize quadratic expression for different cases. First, case c equals to 0. For example, 6x squared plus 3x, when factorized, gives 3x into 2x plus 1. Case 2, b equals to 0. For example, x squared minus 3x minus 3 squared can be factorized to give x minus 3 into x plus 3. Case 3, a is equal to 1. Example, x squared minus 3x minus 10 can be factorized as x minus 5 into x plus 2. Case 4, a not equal to 1. Example, 2x squared plus 6x plus 4 can be factorized as 2 into x plus 1 into x plus 2. So with this, we reach the end of this lesson. I hope that you enjoyed the lesson. Note that there is a second video on quadratic where we solve quadratic equation. I thank you for your attention. Take care. Bye.